database concepts, that is the database management systems. We shall go about this chapter in a particular manner. Initially, I would like to discuss about the ideas of what is a database, how it is different from DBMS and DBA, that is the database administrator. What are the objectives of database management systems? What are the different kinds of database management systems, and why database? I mean, what is wrong with the traditional file based systems? So, this is how we begin. Afterwards, we shall see how to design a database. Basically, designing of database requires two kind of approaches. The first one, you can say the entity relationship modeling, and the second one we can say the normalization techniques, right. Now, therefore, we take up the entity relationship modeling first, a particular diagram called entity relationship diagram that will be discussed, and thereafter we shall take up normalization. See, normalization is a very important topic and it can be covered in two ways. The first approach is to cover normalization from a layman's view, right. Suppose you do not want to go into the nitty gritty of the concepts behind it, but you can still understand normalization by using some very simple empirical rules. So, that approach we shall take first, and after we have built a little bit of understanding what is normalization and how normalization and entity relationship modeling gives the same results, then we shall go into the mathematical side of normalization, right. Then what are the different kinds of normalization, how to obtain them mathematically one after another, and therefore, how an efficient design of DBMS can be carried out. Towards the end, we shall take up structured query language. Structured query language or SQL, everybody knows, is a very important component of any DBMS system. So, we shall take up that. Now, these we may take quite some time, maybe say 5 to 6 lecture classes, right. So, this will be our coverage for the database management systems. Today, let us see the initial concepts. The very beginning, we have to have a definition of database. We can, in a very simple language, we can call database is a collection or a single storage of all related data files, is an integrated concept, right. It is a mechanized, centrally controlled collection of data. But we can put it differently. In a database, data are organized and stored in a manner to promote shareability, availability, evolvability and data integrity. What are these? We shall take up in detail after some time. Now, what is the problem of traditional file based systems? See, whenever we have the traditional file based system, first and foremost, I think I would say the most important thing is the data redundancy and inconsistency. I think this is a very important point. I would like to elaborate on this. See, what really happens is that whenever you have traditional file based systems, you have the same data probably kept in many places, right. That is usually called data redundancy. You are keeping more data than is required. Then inconsistency. Inconsistency means when you are keeping the same data in different files, probably they do not match, right. So, this is known as data inconsistency. As I said, I would like to deliberate on them, but first let us see the points one by one. The second is difficulty in accessing data. Naturally, whenever your data is there in number of files, it will be difficult to obtain a specific type of information. You see, if you just want, usually how it happens in a traditional sense, wherever you have isolated applications, the isolated applications are developed with some specific requirements in mind. Say in an organizational context, let us say we have isolated applications of, let us say, payroll, right. Payroll means the payments to the people, workers, officers, all the other people. So, it should have that what is the basic pay, what is the dearness allowance, what are the various deductions, how many days the person has come to the office, etc., etc. Is there any overtime earning, incentives, etc. So, that is the payroll part. Then another could be, suppose you think of a industrial situation where every job that is carried out in a shop floor, it requires a job card to be distributed to the workers, right. So, you have several workers, anything that is to be produced, a job card is given. Say an machining, right, a job card is there, and this job card specifically identifies, codes the activity and gives a job card. So, we can well understand that we have a job card for every job that is done. So, if the job cards come back to the computer section, then the computer section knows what are the jobs that has been carried out, and naturally which machines are used and how much time has been spent on these jobs, right, and what was the standard time that should have been utilized. A third application could be the machine performance, right. Usually what happens, all machines do not work all the time. So, it may so happen that some machines are under maintenance, some machines are working full time, some machines are to be reinstalled or revised, replaced, so on. All these data about various machines are kept in another application. Usually, whenever the top management or the corporate office wants to do an analysis, they do not want isolated analysis. See, isolated analysis reveals their own story in a summarized manner. What it may say, that machine downtime is 15%, then workers incentive earning is 30 to 40% of their salary, right. The situation of job card distribution is up to whatever was initially thought of in the production plan right in the beginning of the year. These kind of results can be obtained by taking individual data from isolated applications. But can you find out what are the machines, or who are the workers, what are the machines they are working on where maximum incentives are being given? Try to understand. We now want queries or answers to queries which are specifically related. What the workers are doing who are allotted to equipments where the downtime is very high. Which jobs are being done on machines which are not working very well. Who are the people who are working on replaced machines, right. So, if you try to see these kind of reports, they actually tell many other stories which you do not know otherwise. You see, suppose you find that the people have earned incentives, right. The jobs are done on equipments which are down. What does it mean? See, the machines are down, people have earned incentives and the jobs are apparently being done. What are these jobs? Where are they coming from? So, is it a falsification? Is it a deliberate falsification, or what is it? You see, these kind of overall control figures can be obtained not only to find faults, but also to see the trends in operation. trends in operation. Say for example, between the production and marketing, what is the job of production? To maximize production. What is the job of marketing? To maximize sales. But then the two may not match all the time. When the production would like to produce their maximum, the maximum sales may not be at that time, alright, and the sales may be having so much fluctuation that however the production may like to match, they may not be able to match it. So, what will happen? You have to have something called an inventory or a stock in between, alright. Now, what is the exact value of the stock? Invariably, in isolated applications you will find the production will show one kind of stock and the marketing will show another kind of stock. The stock with production and the stock with marketing, it is the same stock, same finished product or finished goods stock. You will find there is a difference. Why this difference? Because they are managing separately in two isolated applications to suit their purpose. Production would like to blame marketing that we are producing, but they are not taking it into their stock. They do not like to show it on the stock, because if they show it on the stock, because they are not selling, they cannot blame us. On the other hand, marketing will say we want lot of material, they are not able to provide. You see, this battle goes on, and therefore, these kind of isolated applications in a way better, because they do not create problems. You can still keep two values, both are there. You have the production side of inventory, you have the marketing side of inventory, although it is should be same, but they are different, and information system keeps two different values and it is perfectly fine. Think about production and maintenance. Say you have an equipment, the equipment has failed at a certain point of time, let us say on a Friday afternoon, right. You have tried to contact the maintenance people, you could not contact, fine. You could contact the maintenance people only at the beginning of the next day, probably Saturday, or if Saturday and Sunday is a holiday, probably on a Monday. The maintenance people came within a few minutes, rectified the equipment and everything is fine. Now, what is the downtime? Is it according to the maintenance, because they were informed on Monday, they would say the downtime is only Monday so many minutes. And if you ask the production people, they would like to put the downtime from Friday to Monday morning. Now, how to resolve it? If you allow two isolated applications, production will keep their kind of logbook, maintenance will keep their kind of logbook. You see, very easy to match, alright, but that is not right. You have to have a single downtime, alright, so that the analysis by taking production data and taking marketing data should be the same. Is it clear? This is where I was telling you that the isolated applications has tremendous difficulty or inefficiency. That is the difficulty of the traditional file based system. How to really do this? You must have an integrated database, right. If you have inventory, there should be only one figure. If you have downtime, there should be only one figure, alright, so that it is easy to understand, or you can have an accuracy of data and a consistent data. That is the inconsistency and redundancy I was talking of. So, you can understand all the related things. You can difficulty in accessing data. If you want cross application information, for example, who are the workers who are earning incentives, high incentives, and what are the machines where they are working on. This is difficult because you have isolated applications, you have to merge the two. Most often isolated applications are run by different sets of people. They do not understand their own language, the different languages. I mean, their data definitions may be different. What you are calling as inventory, the other fellow may call stock, right. So, what you are calling as equipment number, the other person may call machine identification. That machine identification and equipment number are one and the same thing. Who will tell? Actually, the most difficult thing is a realistic problem in any organization where the codes themselves are different. See, suppose think of the students are given a roll number. Every student is having a roll number, and all your academic marks and your grades or whatever CGPA etc., everything is according to the roll number. Now, we want an application. Suppose every hall has got a separate application which got your room number, your mess bills and certain other details about you. Now, we want to merge the two. From a common application, we want all these things available at one go, alright. Your hall related details as well as your institute related details. But suppose hall has given you a different identification number and not a roll number, alright, and that number is not available in the institute database. Tell me, how do you combine the two? Extremely difficult, impossible almost, until unless you manually insert both the codes, you make what is known as a mapping. You have to create a mapping, extremely difficult, extremely difficult. This is one of the very major problems that plagues almost all industry, more so in the materials management. You will find all kinds of materials, all kinds of codes, and two different branches of the same organization do not use the same code. They use a different kind of coding scheme. So, the same material is having different codes, different material has got sometimes same code and all kinds of coding schemes. So, it becomes a very major problem of rationalizing this kind of situation. So, it is easy to say, okay, well, let us integrate, but it is not that easy to integrate. Lot of work has to be done before the integration can actually be carried out. Then data isolation, data is available. This is an example of probably of data isolation. Data is there, but isolated and could not be integrated. Another problem that usually happens is concurrent access anomalies. What is concurrent access? Suppose you have the same data in a particular file, and two people from two different terminals or two different stations are trying to access it at the same time. What will happen? See, lot of such problems can happen. Suppose it is a bank and you are having a traditional file to keep all the account details. Now, you have gone there and you are trying to deposit say 1000 rupees. At the same time, you have written a check of 1000 rupees or whatever 2000 rupees to a person who is trying to take that money. Now, it so happened you are depositing that 1000 rupees. So, the clerk is entering that 1000 rupees you have given, and the person who is taking out 2000 rupees, the clerk has given 2000, the cashier has given him 2000 rupees and he is also entering that 2000 rupees deduction. Now, depending on which transaction goes fast, the results could be different. Suppose your bank presently has got only 1000 rupees, alright. See, lot of things can happen. Suppose the deposit clerk enters fast, then everything is fine, 2000 balanced, nobody says anything. Suppose the withdrawal clerk enters first, then the check will bounce. You do not have so much money in the bank, so sorry, right. This will happen even with database, but if both are concurrent at the same time, what will happen? The program will hang, alright, the program will hang. It does not know, because two cannot access the same file and try to update the same file at the same time, alright. This is the problem of a traditional file without any specific arrangement. What the database does, database nowadays lot of things are happening, but the traditional idea is the database will lock the record. Whenever you are trying to update it, the database locks the record and it does not allow anything else to be done on that record, alright. Some other day we will discuss. The basic idea is that whenever we are talking about a database, a transaction to the database, when the transaction is going on, particularly if it is an add or delete kind of transaction, no other transaction can continue, alright. So, specific arrangement has been made in the database to take care of concurrence access anomalies. Then obviously, there are security related problems. If you have traditional files, right, traditional files, security related problems, like anybody can easily take out data out of that. Whereas, in database you can give specific security measures, so that the data is secured. The integrity problems, you see, all integrity checks has to be done in a database in a traditional file through the program, because the file will accept anything and everything, alright. Say for example, suppose someone writes his date of birth is 29th February 1983, alright. See, such a date does not exist, alright. So, in a database system, this will throw out, this data should not be there, right. Whereas, if you keep this 29th February 1983 in a conventional database, it will accept, right, it will accept, not only it will accept. So, therefore, how to check that this is an invalid date? By you have to write specific code in the program to check it. Whereas, in today's database systems, they have their integrity checks, you can include the integrity checks, the database will not accept such a date. But sometimes you have difficulty in such situations, because I still remember we had to face one such difficulty once, right. The student wrote his date of birth is 29th February 1983. So, when he wrote back that such a date is not possible, the student sent an affidavit signed by a magistrate that his date of birth is really 29th February 1983. So, he had to make special changes in the database to include him. Alright. So, these are sometimes I mean other kind of problems. Now, there are other kind of integrity problems. We had traditional files. Let me share with you. One of the most conventional integrity problems in the earlier files was putting O instead of 0. You see, probably you will never find in today's world, but I do not know, even today those punching machines are still there. Suppose you have to enter huge amount of data, huge amount of data. In fact, some companies may approach some firms that only for data entry, nothing but that. In fact, US government sometimes approaches some Indian firms that look, here are our some 1000 telephone directories, you simply enter it in computer, validate and give us back the data. Now, you have to then employ lot of semi skilled people, and is it really necessary for such work to have sophisticated Pentium 4 computers? Not necessary. You can have simple punching machines which may be costing very less. It has simply a typewriter, you type it out and it goes into some small cassettes which can later on be converted to some magnetic tapes, right. This is an old technology, but this technology is still very much there. Now, in the earlier days what used to happen, some people wherever there is a 0, they used to by mistake enter an O. So, what will happen? You have an O instead of a 0. So, suppose something is 900 and he entered it as 900, but look at this, 900 is numeric, 900 is not numeric. So, if you want to multiply 900 by 5, it will do 900 into 5, nothing will happen. In fact, the program will go crashing, it will stop. Now, try to understand, if you do not have a validation check in your program for each and every such data item, think of a payroll program. In a payroll, it handles with nearly 50 to 100 variables. So, those 50 to 100 variables, if you do not give in your COBOL program numeric check for each of these variables, suppose this particular variable numeric check is missing, what may happen when in the dead of the night 10,000 employees data is being processed, their pay slip is being printed, right. Suddenly the program stopped. See, you have to print 10,000 pay slips, 2,000 has been printed, another 8,000 is pending. The implication could be very high, because next day morning if the pay slips could not be distributed, then the company will face a little bit of difficulty, is it not? So, there the computer people has to be very alert, right. So, these are practical situations, right. At the dead of the night, immediately what will happen, the operations people, they will call up the programmer or the analyst, he has to come running to the center, find fault with the COBOL program, recompile it and rerun the program. These are part of life, alright. So, these could be situations if in the old days. Today what will happen, if the person enters 900, the database will simply not accept it. So, the data will be thrown out. See, please understand, throwing one data is not that bad, even throwing 10 data is not that bad. What will happen? 10 workers slip could not be printed, but you can still print 9,990. You see, in the middle of night, if the whole program stops, then nothing is printed. Instead, if a few errors are there, you can always take care of 10 special cases by manually or by any other means, alright. So, these are the things which are very important. So, on the other side, with compared to the okay, I will just tell, just one of you inform. So, database characteristics on the other side is, the first one is coordinated updation, right. So, whenever you are updating, the updation is done in a coordinated manner. That means, not only we have between the two file systems, but also the say between production and marketing, you can decide who will enter what, alright. Then high quality and recency of data, high quality and recency of data, data security, data compatibility, no data duplication and a logical concept of data. So, I will explain them one by one. The first one is the coordinated updation, that whenever you are updating your, since you have a common field, then all the entries are taken together. The high quality and recency of data. Recency of data means, see, if you have multiple files, any update you may have to do in all the files. Many a time what happens, whenever you have isolated applications, suppose the personnel department has all the employee details, alright. Now, if these data you are also keeping in individual departments, okay, fine. So, you think, why I have to go to the personnel database all the time, let me keep my own data. So, every department keeps their own personnel data. Unfortunately, what usually happens after some time, the personnel department, because they are a regular department, that is their job, they will update their data as and when new things are coming. For example, a person has earned promotion, a person has got increments, a person has got new degrees, etc., etc., all are being updated. Whereas individual departments, it is not their responsibility, alright. So, they do not enter, because they are not entering, their data will remain old, alright. This is why the question of recency of data comes in. So, the idea is you integrate the data, alright, and with a specific instruction who will maintain the data. The basic concept again is data should be maintained where, or data should be updated where it is generated, as near to the point of generation, alright, with specific permission should be granted. That means, if I am responsible for updating the data, only I will update the data, others will not have the access of updation, alright. So, we will come to that. Then security of data can be there, data will be compatible, production and marketing will see the same value of inventory, they cannot see two different values of inventory. No data duplication, as far as possible we should see to it that data duplication is to the minimum. And the logical concept, see, for every physical database you can define a number of logical databases. I will come to this point, we will explain in some detail. Now, this is a comparison between the conventional files and relational databases. The criteria, suppose ease of use, right, we can say easy, complex. See, the relational database is not that easy to use. So, this is one difficulty. And data duplication, present, reduced, fine. So, conventional files are known for data duplication, data sharing, conventional files none, relational databases shared data. Data is shared across applications. Update anomaly, there is an update anomaly and data is inconsistent, and in relational databases there is no data anomaly, should be. Data integration, absent, integrated. Initiating change is hard in conventional files. If you want to make a change, it is difficult, whereas it is easy in the databases. Flexibility and scalability. What is flexibility? Flexibility means change of fields, change of data items, etc., etc. And what is scalability? What is scalability? Scalability means upgrading by adding new features, alright. The scalability considerations are very important whenever you take up a database development, right. Say for example, if you are thinking of today, suppose your roll numbers, look at your roll numbers, it is an 8-digit roll number. Few days back we have had only a 6-digit roll number, alright. See, when we have, let us say, allocated codes for departments, allocated codes for department, that time we had given something like 52, 40, etc., different numeric codes. Today we are giving alpha codes, E, IM, etc., right. So, the point is, at that time while the codes were allocated, at the times when the codes are allocated, we should have seen that there should be provisions for doing these things in an efficient manner. I do not know whether you are getting the picture. Let me give you another example. See the railway reservation system, right. Sometimes what happens, particularly in the summer time, there is a huge rush, and there is a rumor sometime that some summer special trains will be announced, right. Now, in view of these, that there might be a summer special train, lot of people they book ticket in the existing train and be waitlisted. See, usual wait list may be within 50 to 100, but if people know that there will be an summer special train, so let me have a booking anyway. So, suppose there are some 750 wait listing. The earlier software that the railway people had, there was a difficulty that they kept an arbitrary upper limit of wait listing passengers, alright, and there was a little bit of anomaly somewhere in the design, right. So, what happens, the 750th person or even more has been registered, taken, ticket is given, but the system crashed, alright. So, when this system crashed, what will happen? For next 2 days nobody got the facility, is okay. It is not the system crashed means system crashed in Kharagpur, the system crashed, that is all over, right. So, this was an particular incident I am just citing from newspaper. So, what probably had happened when the initial system was thought of, that time they could not imagine that it could go up so high, alright. The people thought, okay, wait listed passenger means 100, can it be 750? Too high, but how high is high? Very difficult to tell. See, when the computers or personal computers first came, our very own Bill Gates, who wrote the disk operating system or DOS, original DOS was written by him, MS DOS. So, he kept an upper memory of RAM as 640 KB. Think about it. Today, even 640 MB we can think of, right. When he took an upper limit of 640 KB, today it is 1000 times higher, 640 MB. So much difference can be there. And particularly in database design, you must always remember that it is the exception that is important rather than the rule. Suppose you want to design a database for student results. So, you are going and talking to the academic section people. Say you ask that how about failures of BTech students? The result will be what failure? Nobody fails in IIT, alright. Nobody fails because 99% or 99.99% of BTech students pass, nobody fails. So, we assume nobody fails? No, sometimes 1 or 2 student fails. In how many subjects? Oh, some 1 or 2 subjects, like that. So, by thinking or believing him completely, you keep a provision in your database, the total number of backlog subjects that a student can have should be between 0 and 9. So, you keep a provision for 1 digit, that is all. Now suppose due to whatever reason a given student has failed in 10 subjects, what will happen? Because you have a single digit provision, his data could not be kept in the database. See, it is not that his data could not be kept, the problem is immediately you do not know what to do. Is it not? You see, people who are working in computer sections are very busy all the time. Now, if they have to make a database change, see, any database change is risky. You must understand the importance of the thing, because you have the live data of all the students, all their current results, which are meticulously entered, data is validated and entire results is there. Tomorrow someone wants a transcript, you have to print and give him. Now suppose you want to make a database design change and suppose something goes wrong, that means you have to go back to your backup tapes, recover all the data, and it will be a crisis situation. Is it all right? So, all the time you must keep in mind these sort of things. This is actually called evolvability, we will discuss later. So, those are things. Then cost and design requirements, like should be, if you want lot of facilities, you have to pay for it. Today's sometimes some sophisticated Oracle softwares could be very costly. In fact, more facility you want, the better platform you want, more is the price. Suppose you want Oracle for personal computers, it may not be that costly, but if you want Oracle for Unix based systems, you want it for the Sun systems, it will be very costly, right. So, those are the some of the things. Now, between database management systems and database administrator. See, the first one, the database is a mechanized centrally controlled collection of data. I have already told you. The DBMS is actually a software, right. So, DB is the data part, the collection of data. DBMS is a software to manage the database collection of interrelated data and a set of programs to access that data, and database administrator is a person, right. Whenever you have a database, you must have a database administrator, who is actually representing the organizational authority over the database. That means, if you have a database, the database administrator will look after the activities of database, means he will see to it that the data is entered and data is managed, data is maintained in a perfect manner. So, this is the difference between the database management system and database administrator. We will come back to this little later. Then let us see the objectives of database management system. So, these are the 5 fundamental objectives of a database management system. First one, availability, shareability, evolvability, data independence and data integrity, right. These are the 5 objectives, major objectives of the database management system. Let us discuss them one after another. The first one, availability. Data should be available when the user wants to use it. For efficient storage, updating and retrieval, purposeful information retrieval. Shareability, data shared across applications, right. No data is owned by an application. Minimization of unplanned redundancy. Okay. So, these are things, and database should evolve with time as applications and query needs changes with time, right. So, this is what I was talking about while talking about scalability, that is, database should evolve with time as applications and query needs changes with time. Now, these availability, shareability and evolvability, let us take an example and try to understand in a slightly better manner. should I? Okay. Right. Now, I have missed something. I have missed E code. So, E code also is a part of these databases. Now, I have written here two sets of employee details. Now, actually employee details are not these only so small. Usually in employee details we have somewhere between 50 to 100 fields usually, right. So, I have written only 5 probably. So, it is just a very what you say sample. Let us just take only 2 departments. Now, similarly, there may be other departments. The personnel department keeps employee data, that is the name, address, his basic pay, the ACR grade and the training needs. Obviously, employee code or E code is the primary key. Now, look at this. This ACR grade is a confidential information. ACR means annual confidential report. What was the grade given to this employee in his annual confidential report, and what are the training this particular employee needs? This is what is there in the personnel department details. Whereas, the marketing department keeps the employee information, basically code, name, job assigned and performance. Alright. Now, see what is the need of these. Basically here you have the employee code, you have the employee name, what is the job given to him and what is his performance. Is it okay? Now, look at this. If there are two isolated files, all the difficulties which we have discussed will come in. The marketing data may not be updated, the name in these two files may be different, for the same code two names may be found, all these various update anomalies may actually come in. Alright. So, suppose we want to make it an integrated application. Moment we want to integrate the applications, so we can create a third file which should have e-code, name, address, basic, job assigned, performance, ACR grade and training needs. Alright. So, all the fields will come into this. So, this is our integrated DB. So, integrated DB is having all these: employee code, name, address, basic, job assigned, performance, ACR grade, training needs. But if I implement this, there will be problems. What will be the problem? The marketing people may get access to ACR grade. The marketing people may get access to training needs. Similarly, the internal performance reports which the marketing people are writing, personnel people knows about it. They do not want it to happen. Is it okay? So, one of the basic needs of the database system is that, see, data should be shared. We talked about availability, data should be available. See, we are sharing the data, but at the same time we want our data to be available, but we do not want our confidential data to be known to others. So, answer to this is, we call it the physical view, and it should be possible for every physical view we should be able to create logical views. Fine. So, for every physical view, if we can create these two logical views, and these logical views are given to personnel and marketing, so we are achieving the same thing what we were having earlier. The data is shared, the data is available, we are getting advantages of databases, but when personnel department looks at these data set, it does not find job assigned or performance, right. When the marketing department looks, it does not find ACR training needs. In fact, if you want, you can give him something like address and basic, some additional information which can be shared. Is it okay? So, this is the advantage. Fine, we stop here, we will continue the discussion next class.